Okay, ready to go? I'm part of a marine consortium run out of Lumcon with about, we've had 2-3-year segments of funding from Gomery, and there are about, at one time, 15 individual institutions, 26 PIs on this, well-funded, but there are a host of problems to look at from this. And so I'm going to skim over some of the results we have so far. And Dr. Roberts will talk about the biogeochemistry of the sediments and the marsh system following me, I think, sort of afterwards. So the idea is we have the money from Gomery, it's delivered to Lumcon, and it's distributed to these institutions which go from Woods Hole to Louisiana. There's quite a few of them. It's not just a Louisiana project. So to start off with, we normally think of oil as being oil. So it came here as moose. But if you look at what's in the water, you can't drive a small boat through the oil. Nancy went down and came up through oil, the moose, and had it in their hair. But if you take a normal sample, you wouldn't put your boat to have the engine cooled with this mousse. So generally we don't sample mousse at all. We sample the water. And there's hardly any oil in the water itself. There's no small droplets going around. So for the offshore, before it came here, I'm going to show a bunch of these squares which have what we expected before and what we found afterwards. And I'll have to skip over the details on these. But for phytoplankton community offshore, we have found, we did have a baseline. That was one thing we pleaded with the funding agency before they started, which took about a year before we got money, was that we have to have a baseline to work on. And we didn't start off with a strong baseline. But offshore, we did have a baseline of the phytoplankton community, and we did find through marker indices that there was an effect on the phytoplankton offshore. And so now we're testing that inshore to see if we can find the same markers. We did find offshore, of course, we had a hypoxia that year, and it was incessantly, we had, I spent at least an hour every day with reporters, and they would say, well, how bad is hypoxia going to be because of BP oil spill? And I say, well, we don't know, but if you look at the ballpark, we don't expect to find much of an effect because the main driver is the Mississippi River. And they say, well, how bad is it going to be? And I said, we don't expect any effect. Well, does that mean it's going to be huge? And we go over this again and again, and then they'd hang up on you. So we did find, maybe in 2 stations, some effect of carbon oxidation on the offshore area. But we really didn't find any difference in the hypoxias on offshore that summer in August than we did any other year. It was driven by the regional effect. So now inshore, which will consist of most of my focus here, there was these, if you're not familiar with these graphs, these are surveyed, they're called scab analyses. And the red is the hottest area of oil on the shoreline as they drive by, and they go in and they have a protocol for that. And the blue means that basically none at all. And you'll notice a lot of the oil came into Barratera Pass and turned right and oiled Bay Jimmy, but there are a lot of areas as well. So this was about, I think, 1,741 square miles of shoreline. It says nothing about how far into the marsh it went. It just says that the shoreline was oiled. Now, if you drove by, you might confuse some of the oiling. I'm not saying they did, but if we drove by, you might see some of this dark area on the beach and you confuse the rack with the oil until you go look at it. So they did a pretty good job, and they went through multiple times over the next 3 years to look at how much oil was present in terms of being visibly present, but it was not measured. So if you look at I'm going to focus on this graph. If you look at the kilometers of shoreline, most of the marsh was in Louisiana that was oiled. And this is the heavy, moderate, and light and trace elements. So almost 80% or so of the oiled shoreline or more was from Louisiana. So we have been looking at how much oil is in the marsh, and the pH is the main element or group of molecules that are of concern. These are petroleum aromatic hydrocarbons. I've learned more chemistry than I want to know, and probably you would want to know. But these are the aromatics which are defined by individual test organisms often to be carcinogenic and harmful. And they represent about 5% perhaps of the total suite of molecules that are in the oil. Now most of the lowest one that we measure, and this is common across many labs, is naphthalene. And when the oil came ashore, there wasn't much naphthalene in it. It had blown off. So these mostly are heavier ones. So what's plotted here, and this is important, this is the baseline in red. We were able to get out there with no money for anything, and guards on boats telling us not to do this or that. And we were able to sample a whole bunch of spots in the marsh, which we didn't know where the oil would end up. And we did get a baseline. And I don't know why we did it. Well, I know why we did it, but it's pretty remarkable that we got this done. And we used the same methods for many years after and are continuing them to look at how much oil is there now. And this is a log scale on the vertical. So what we have is down here is the alkanes, the alkanes and the aromatics. And the aromatics are the black. And the aromatics, I'd say, are the main thing. So this is a scale of 1, 10, 100, 1,000, 10,000. We had 100, in the 10 to 100,000 range of increase in the amount of oil on the marsh on the average. The oil came ashore not as a blanket material. We have one site, we have a spacing of 30 over, I don't know, 10 miles, 5 miles, samples, and you could go 10 meters away and you'd find no oil. We had absolutely none. It was very spotty to begin with. It wasn't a sheen of oil coming across on the marsh. And then we sampled into the marsh 100 meters. We didn't go any further, but we flew over it. And we find just as much oil at 1 and 10 meters as you would far in the beginning. This is in the first few months. So it wasn't just an edge phenomenon. Perhaps it came up as a greasy mousse in the first few meters, but it spread throughout the whole marsh. And it became obvious after Isaac, which is more than a year later, that the oil was lifted up from God knows where and brought into the marsh, because the water level has a seasonal cycle where it's low during the winter and high in the summer, the end of the summer in particular. And a hurricane came up and rose the water, 2 meters over the marsh. And it redistributed the oil and re-oiled the marsh again. So there were multiple oilings on this. And so, just draw this attention to you, is that it went from a baseline here and here up to there. It's at least 10 or 30-fold more. And that appears to be like the new baseline of oil for the marsh. Is that what we had as a baseline at one time from our, as Dr. Twilley called it, working coast, we have oil from a variety of sources, including the plants themselves. But they are petroleum hydrocarbons. And we were able to identify the first oiling as Macondo. Now it's become aged and the molecules have changed, and getting a signature for that definitively is difficult. But at any rate, the baseline has definitely risen for all the marshes we sampled. And we're sampling Terrebonne around just north of Cocodrie, on the east and west side of, east and west side of Barataria, including the Bay Jimmy area. So we're continuing, in short, basically 13 sites twice a year to go out as a group to go look at the marshes to see what's happening. And originally it was set up as an oiled and oil dichotomy, but it's turned out to be that a lot of the oil sites have become oiled slightly because the whole marsh has become, the whole marsh of Barataria Bay, as salt marsh, has received oil. And subsequent re-oilings, they kind of get remixed within the marsh and among different marshes in the area. So one aspect then was that we thought the oil would disappear rapidly. This does happen in sandy coasts. It has happened elsewhere. These are microtidal coasts. But we found out that it didn't. It's been retained, and it has dropped. It has gone down. It could be from mixing. It could be from dilution. It could be from decomposition. But at this point, it's definitely still there, and it's going to be a lifetime of, I don't know, decades for some of this stuff to go back to a baseline if nothing else happens. It wasn't a single oiling, it was a single initial oiling, but there have been multiple oilings afterwards, each of which perhaps is lower than the initial one, but is significant to the marsh. So two processes we saw on the edge of the marsh that we could describe from this oiling was that first, the initial oiling led to a collapse of the marsh in some places. Other places did other things. And so there's this general root structure underneath. These are organic soils for the most part in deltaic plains. They're not mineral matter. There is a tip on the delta around the river, around the Chafalaya, but in between are this deltaic plain. It's mostly organic matter. And the plant itself is buoyed up by this organic matter. And that was killed off, and so it sank in place. So it just dropped. The second aspect is that there was an undercut. The surface plant was okay, but somehow or another the material at the edge, in these marshes at least, was undercut. That was another mechanism. So what happens is the plant would be hanging out 30 to 40 centimeters at the most, and then it would separate off and fall in. It would be a live plant. It works photosynthetically like a live plant, but it doesn't have the base beneath. The 30, 40 centimeters below that is just falling off and going into it. And so what happens to the oil sites is one of these secondary effects, and this is from Bay Baptiste, is that if you have this spotty oiling coming in, and it erodes it here, either from subsidence or undercut, that leaves the protected areas that haven't been oiled as promontories. So over the next 2 years, these promontories are going to erode faster than they would otherwise. So you could slow down the oiling in the inset part of it, but these promontories of healthy marsh are going to be attacked more strongly by the wave energy because it's going to hit them because they're sticking out. And so they erode faster. So that's an indirect effect on it. And we didn't expect that, of course. So that's something. And so on the expectations, we thought restoration would be predictably successful, that erosion rates would be accelerated. They were accelerated up to 3 times faster for the first 18 months or so. And we're trying to figure out how long it's going to last before it goes back to baseline. And there are these local effects from the spotty nature of the oiling on it. And the thing to point out about this is that the erosion is forever. We don't have any sites in general unless you treat them, as Dr. Zingel will talk about at the end. And most of these marshes, there's too much area, will not be treated. And so the erosion is forever. It's not coming back. We found the places we looked, and we looked at a lot of places, they may have greened up for a while, these subsidence sites, but they have not come back, and they're not going to come back. And so if you figure out how much an erosion rate of going up 3 times faster or twice as much for a year or two, you've got a lot of miles that were of shoreline that were oiled. So it actually only ends up being a square mile per year. Right? That sounds like a lot to another state. To our state, it's still a lot. I don't want to lose 1 acre. But we permit that much every year. Every year we grant a square mile of permitting. And for every mile of permitting, there is an indirect effect from that permitting of about 5. So we have a dramatic effect from the oil. It's significant, maybe a square mile, but we're also on the side allowing that much to happen because it's legal. And so as Dr. Twilley was saying, if you look at the erosion rates on our coast and you plan out the cumulative canal density in 15-minute quads, all the deltaic coast plots up really well with land loss and canal density. But on top of that, we've added an oil spill effect. So to look at some of the effects of the oiling on the marsh itself, I'll go through some food web analysis. I won't go into your safe part. So the oil has come ashore. Now what's happened to the marsh because of that and what's happened in the water nearby? So one thing on the microbial diversity, we didn't notice this, other people are. There are quite a few other people out there with grants of various sorts. Well, one is the microbial diversity definitely went down because of the oiling. Now, so what's happened is that the oiling has created a new niche of specialists for mostly oil or poison or made inaccessible to other type of microbes. And I just bring I'll never get this. So that's total pH is on the bottom. And it appears that the oil content now is below where that starts to drop off. So perhaps the microbial community, as a general rule, but not the individual cases of microbial specialists, has reached perhaps the baseline for this particular indice. It doesn't mean it's the same organisms. It only means that the genetic diversity has come back up again. But it was definitely affected by this. That's from Atlas. There's a paper in Environmental Science and Technology. So another thing is, on the oil, if you don't go out there, you may not realize you're surrounded by little critters besides crabs. There's ants, and there's stinging caterpillars. There's things you might not necessarily want to do if you go for recreational fishing, but there's lots of organisms out there, and one of them is inside the stem of the plant. And we found that a few months after the spill, but not during the spill having ended in the fall, there were more ants in the oil sites than there were in the unoiled sites in September. But then in June, you can see the plots going across the top in time, gradually in April 2012, which is 2 years later. There were no ants in the marsh, in the oil sites. And now it seems to be that it may be coming back to, after 3 or 4 years, some of the ant community, just these acrobat ants are coming back. The Seaside Sparrow is a resident bird. It stays there 12 months a year, and it has a decent-sized home range, but it's workable. And so there have been people going out with field crews in the spring looking at the nesting success and reproductive health of the organism, of the future sparrows. This is a picture of one of them. Some people have a sense of where the nests are, and other people don't, just like they do for ants. It's amazing how different we are in our skill sets. But at any rate, they went out, and in 2012 now, which is 2 years later, these are significant differences with the red. The fledglings are less. Everything else seems to be about the same, but the fledglings are less in the oil sites compared to the unoiled sites. And that goes and in 2013 as well. So that's 4 years later, one of our resident little birds. And you probably only hear it chirp every once in a while when you're out there. And we can't look at everything, but we can look at this one. So there's effects that have carried on. So we have ants that maybe have a 6-month delay, and maybe even a little bit of help the first 6 months, you might say. And we have birds that 4 years later haven't recovered. We also have loons out there, which are in the water body, of course. And the loons are migratory. They're here for only 3 or 4 months a year. And these are some pHs in the blood tissues and the plasma, the blood. And it looks like from 11 to 12, it went from, remember, 2 years later, all of a sudden we started seeing more pHs showing up. They're going to be fish eaters, so there's some kind of a lag effect going on. And so there's a higher incidence of loons with total pHs and a higher amount. And these are levels which, in terms of individual organism examinations, these levels are detrimental to the life of the loon. So 3 or 4 years later, there are still these effects. We don't want to go ahead of the data on this. We've collected more data, but I can't show you more than that. For oysters, we couldn't find anything. We had plates put out to look at colonization, and they looked at reefs for the first 3 years, and we kind of expected that they would shut down. We didn't find any effects for the first 2 years, but in the last several years, in the lab studies, and there has been an effect. We don't know if in terms of the commercial fisheries it's been significant, but in terms of the individual organism, they are significant years later. So there is this delayed effect off of this. And the way the funding mechanism works, they only figured this out at the end of a 3-year funding cycle and weren't funded for year 4 and 5. If they'd found it in year 2, they would have been funded for years 4, 5, and 6. And so we're trying to follow this up. The science community is. For fish, it's interesting that we can find, there's a little mummy chuck in there, people get them for bait fish. You can find, we find pHs in the fish, and we know that they have a response to that pH, and it's not healthy, it's toxicological. That's at the individual level. We can't find a community level response, that is the whole population of fish. We can find what happened to that individual fish. We know it's effective to that fish if it's exposed. We don't see an effect on several types of fish as a population of fish, or harvested fish, or whatever. That doesn't mean it doesn't exist, it's just that we can't find it. And that's true across the literature. And we can find individual examples, but can't find population examples. And again, that's a no result. It doesn't mean there isn't a result, it just means there is no result for what we've looked at. We may be looking at the wrong thing on this. So there is a lot of complexity to this. There is many mouths for one piece of dead organism, and it's a very tangled bank, as Darwin used to say, many feeding cycles. So what we expected before, we would have marsh fish affected. We did find some effects, but not at the organism level, but not at the population level, at least not yet. And that'll give rise to analysis of food webs, which we're starting to do more explicitly with this funding cycle. It's a complicated food web. It's not a simple catch them and kill them, or oil them and they die. There are a lot more linkages. We have these delays for the ants, we have them for the birds, the oysters, and perhaps other organisms as well that we've already identified. So just to give you an idea then, this is an example I'd like to put up for baseline shifts. We've had a big baseline shift that happens slowly in our perception from year to year. And this is the fish, trophy fish, caught from 1957 to 2007. And it's obvious from the graphs, you know, what used to be a trophy fish in 1957 and 1980s, they're much larger in 57 than they are in the 80s. And now, of course, in 2007, they're even smaller yet. This is the same dock, the same picture, the same regatta, and much smaller fish. And it happened kind of incrementally, slowly, you know, 1%, 2% a year, a decrease in size from one to the next. And so that's like a lot of habits. It's something we need to pay attention to in terms of an oil spill, which has this dramatic effect in one year, and we also have these incremental cumulative effects from all other factors, including the oil, as Rob was saying. So in terms of a summary then, we had this dramatic effect from the oil. We have multiple re-oilings. We had multiple stressors already, and we have these chronic effects underneath. And so we need, there was an awful lot of attention to this dramatic event, and I'm glad that there was. But we also have a lot of cumulative effects that are happening underneath this for this shifting baseline that's, as Jeremy would say, Jackson would say, and others, that happens underneath. We don't see it happening because it's such a small amount every year. So we knew a lot before. It was our expectation, and we thought maybe we just missed a few pieces. And what we found out is that, well, it's the other way around. It's pulling the pocket inside out. We actually knew very little, and we need to know a lot. And it's a lot less that we know than we need to know for managing properly. And we have to make decisions, but we still could use a long-term baseline, which is one of the chronic things that we have all found. Almost every one of us would say if we had a target outcome from this oil spill is that we would have baseline measurements continuously. And if you realize that the baseline is shifting from other factors all the time, you need to measure things all the time. It's just not once in a while, and fixed stations, year after year, to keep going with it. And that's pretty much what I just said. So in terms of resiliency of this marsh, it is a working coast is the phrase, which kind of sounds like an excuse to damage it, to me. But are we looking at the resiliency of the coast in terms of an environment that works for that society is developing on, or is it the other way around? Is it an environment to be used temporarily by some society and used for an economy underneath? So I think that's 30 minutes, right?
25 minutes and 10
All right.
seconds.
So we have some questions after that, but that's basically what I had to say. Thank you. And we don't want to go too far into the other talks, but there are people from the consortium that are scattered about in the audience that could answer questions better than I could, probably, or comments. Yep.
Did you look at some epiphytes in Marsh, such as paragraph snails? What concentration?
If we looked at epiphytes on the marsh, so there are epiphytes on the plant and there are epiphytes in the plant. So, and we have some people doing wipes of the plant, but that's really just started. Our group is not doing that. Oh, well, they might, no, I don't think they're doing it right now. We're doing photosynthesis of the plant. It's at, 13 places twice a year. And as Brian will talk about. Yeah, not the first year. Right. Can you all hear the responses? Is that okay?
We'll touch on it a little bit later.
All right. Thank you.